Okay, if you want to post that to Telegram, that would be great.
Just give me a link, or I will find it.
It's in the, here, just a second, I'll find it for you. It's in the meetup invite.
Okay. Yes, I found it.
Great, okay. And I'm pulling it up on my host just so I can see what's going on. Okay, and I'm just checking the link from there. All right, we're live. Okay, so that's, we're coming up on 11:56. We'll get started in about, we can start right at the top of the hour and then people can trickle in. There's going to be a lot of stuff going on. So for those of you that are joining us, welcome. We'll be starting in just a minute. Looks like we've got 7 or 8 folks, and so we'll be right with you. Okay, while we're getting started, for those of you that are online, if you want to go ahead and just post something in the chat and just say hello and where you're from, that'd be great. Looks like people are starting to pile in. We've already got 10 people. It's increasing quickly. So just go ahead and introduce yourselves. Excuse me. Oh, let me do one thing. I'm going to go ahead and enable comments on the live on the chat. Let's see, or on the live stream, so we can pick them up there as well. Let's take me a second. I'll get that introduced in a minute. All right, so videos. Okay, so we have, actually this was not public, so I'm just fixing that. And I'm also going to enable comments. This will take me just a second and then we'll get started. Let's see. Okay, looks like it's showing chat as being disabled. All right, I'll have to work on that, but location. All right, I'm not going to get tied up on that. I think we can get going. It is 12 o'clock. It's 12 noon here in California, and I'd like to welcome everyone to the to our virtual office hours meetup. Got a bunch of you. We're using webinar format because it's just easier to manage, and so wonderful to have you all here today. And what we'll be doing, my name is Robert Hodges. I'm CEO of Altinity, but more importantly, I've been working with databases for a really long time. I'd just like to give a really brief introduction to what the agenda is, and then turn it over to our presenters. So we're going to start with a short slide presentation from Alexander Zaitsev, who's going to talk about ClickHouse news and updates. Our other presenters may chip in with additional information. So that'll just catch up on a few interesting things that have happened in ClickHouse over the last few months. Of course, ClickHouse is so big and so active and has so many contributors that we're not going to cover everything, but it'll give you a sense of some of the more interesting things that have happened recently. Once that's done, we'll dive into virtual office hours, and that's most of this presentation today. We're proud to have 3 of the top worldwide people in ClickHouse on with us today. We have Alexei Milovidov. He's the original designer of ClickHouse and the lead committer. So if you go and look at GitHub, he's the guy. He's the man who's sort of controlling basically what goes in and guiding the community development effort, as well as the team in Yandex. We're also very glad to have Denis Zhuravlev, who many of you may know as Denny Crane. And he's waving now. He's the guy with the IBM 360 in the background. Denis, as you probably know, if you use ClickHouse, is the most, just about the most active contributor on Telegram. And so if you have questions and you've asked them, there's a good chance you've met Denis. And then finally, Alexander Zaitsev, my friend, as well as the CTO of ClickHouse, or excuse me, of Altinity. And so Alexander's down at the bottom. And Alexander is one of the first people that outside of Yandex that did a major migration about the same time that Cloudflare and others were beginning to jump on ClickHouse in the United States. Alexander was converting from Vertica to ClickHouse, and that's how he got the idea that he wanted to start a company to help people who were using it. With that, I'd like to turn it over to Alexander, who's going to do the presentation on interesting things from ClickHouse development.
Thank you, Robert. Good time of day, everybody. I don't know where you're connecting from, but probably across the globe. So today we'll start with some ClickHouse highlights from October 2020. This is absolutely not a full list of features that has been added to ClickHouse in the last few months since we last talked about that. And it doesn't cover a lot of interesting developments, but it covers a few important things. And I would like to demonstrate and discuss some of them, and we can then turn to some open discussion about everything that you would like to know about these features or other features or some future roadmap features and so on and so forth. So ClickHouse, other last 4 years, since it started in Yandex probably, how many, 12 years ago, right? So it rapidly develops from something which is very, very focused to a particular use case and scenario to a mature database. And then develops in many different directions, in performance directions, certainly in the feature directions. And we see enormous amount of feature contributions from the community, also usability direction and security direction. These are probably the mainest ones. You can also find some others like integrations, durability and reliability, but those are the main ones. And today I will start probably with the security. I selected actually 6 features that have been added to ClickHouse recently, and probably not very well documented, discussed, and even used, because this is very new. First, I would like to tell a bit about LDAP authentication, and this is what we at Altinity helped to develop. How you can integrate LDAP with ClickHouse, how you can store users, ClickHouse users in external user directory. Then I will show you absolutely new encryption functions. So ClickHouse now has an ability to encrypt data using functions encrypt and decrypt. Certainly it's not as mature as you can think of some other databases, but quite interesting. Next, I will talk a bit about new in-memory parts. They are not particularly new, they exist for several months already, but this is a part of this longer-term projects which is going in ClickHouse, and it's interesting to see how it evolves. Quite recently, there were added durability features that allow you to sync data to the disk and make sure that if your ClickHouse server crashes, then your data is not corrupted. Normally, if you have replication, you don't care because you always have replica to recover from. But if you don't have replica, then durability features might be very interesting. Next, I'll show details for data recompression. As many of you may know, ClickHouse has a lot of ways to do something as the time goes, and this is controlled by TTL expressions on merge state table. And the new addition to the gang is ability to recompress data in the background after a certain amount of time. Then I will show you something very cool, which is called custom settings. I don't know why this feature is not advertised on every corner, but it allows you to do something like variables in ClickHouse session, and you will see some interesting examples where it can be useful. And last but not least is column transformation feature from Amos Bird, who is probably one of the biggest committers from China, and he's working for China's Academy of Science and does a lot of good things for ClickHouse. And this is kind of strange feature that I'm pretty sure that not all of you know, but it allows you to do some fun things in ClickHouse that you cannot do in other databases. Some of these features were implemented by Altinity by request of our enterprise customers, in particular LDAP features and encryption, but the majority of core functionality is coming from Yandex, and Alexey Milovidov will be happy to answer all questions about that. So let's start with LDAP. For LDAP, we right now have 2 different use cases that are implemented. First is an ability to authenticate a user externally in ClickHouse server. Why it's important? Because you don't have to store passwords in ClickHouse in this way. As you know, ClickHouse stores user data in XML files or in recent ClickHouse versions in special user storage, which is controlled by SQL, create user, etc. syntax, but it's still stored on ClickHouse server. Quite often it's not convenient, especially if you need to rotate passwords and things like that. So an ability to authenticate user in some external authentication service is very important. And this is what external authenticator is doing. It allows you to configure certain users to be authenticated by external LDAP server. So if a user comes to ClickHouse and enters a password, the password is not checked in ClickHouse. It's sent to LDAP server and being authenticated there. And second use case is external user directory. And in this case, you even don't need to configure users in ClickHouse. You can store users in your external LDAP server. And when a user comes to ClickHouse, ClickHouse goes to this external user directory and checks if this user exists and if it needs to be granted an access to the database. This is not a full picture, and we still continue to add functionality, but these are two main use cases, and I will show you very briefly how to configure it. So first, you need to configure LDAP server definitions inside ClickHouse configuration file, config.xml, and it looks as easy as shown on the screen. You just add any number of LDAP servers. And for LDAP server, you specify connection parameters and some LDAP specific stuff. On the second step, you need to configure that particular user is authenticated by LDAP server. So we don't store password here. So instead of specifying password, we just specify that this is LDAP and it's located and it should be authenticated using my LDAP server, which we configured earlier. The feature is available since 20.7 already. So it's 3 months old. As you can see, we can configure multiple LDAP servers. So if you have, I don't know, very diverse environment with multiple LDAP servers, you can configure it in a single ClickHouse server. External user directory is very new. It has been merged only a couple of days ago, but the feature itself has been completed in August. Since then, we were doing extensive QA of this functionality, as well as making sure that it is as of the highest quality as possible. And in order to configure it, you need to go to the different file and specify that you have user directories. For user directory, you specify a server and set of roles that should get users that are authenticated or stored in this external directory. This is certainly not flexible, and you can already see the gap here. So if all users have the same role, then how can I manage the grants, roles, and permissions? And this is why I say that this project is not complete. And now we are working on adding roles mapping. So if we look into a roadmap for LDAP, then we started with external authenticator. Now we added external user directory. We are adding authentication cache. So you can, authentication in LDAP can take quite a lot of time depending on network and other things. So we don't want to authenticate every single request. So instead, we will add a cache. So the authentication result will be cached for configurable amount of time, and you don't need to check the user every time. And the next is flexible role and group mapping, which is currently in progress. And it will allow you to map roles in LDAP with roles in ClickHouse and manage grants and permissions on database side, provided that you have the same roles and you understand what the role in LDAP means in ClickHouse server and vice versa. The next interesting feature.
Yep. Alexander, could I just jump in for 1 second? I'm sorry to interrupt. For those of you, as you're listening, if you have questions, you can pop them into the question and answer box. And then as soon as Alexander is done, we'll also, if you want to ask questions directly, you can raise your hand and we'll unmute you and let you ask. So just to let you know that if you are curious about this and want to learn more, please do use those mechanisms. Thank you.
Absolutely. Thank you, Robert. So next feature that I would like to discuss is encryption. So we have added few encryption functions. Actually, these are two functions, one for encrypt and one for decrypt, and also a somewhat relaxed version for MySQL compatibility. IIS encrypt MySQL and IIS encrypt decrypt MySQL that do exactly the same thing that is going in MySQL. So if you have your data stored in encrypted in MySQL, you can pull it to ClickHouse and decrypt using those functions. Funny enough, but MySQL doesn't follow the standard. That's why we had to implement two versions of that. One which follows the specification, and another one which follows MySQL. So what is supported? For IIS, this is actually quite difficult standard. And in addition to general structure of encryption and decryption, it's possible to plug multiple ciphers in there, and every cipher can also be in three different variants depending on key length. So if you use encrypt function, then you can specify mode, and the mode is constructed as shown. It starts with AES. So in the future, we envision that somebody will add support for other encryption standards. After the standard, you add the bit length and then the cipher. So given those combinations, you can actually produce 3 by 1, 2, 3, 4, 5, 6, 7, 8, 24 different encryption modes. So how it works? This is just an example how you can encrypt hello world with IIS 256 CTR cipher, and how you can decrypt as easy as this. Certainly, if you add encryption, you may be concerned about performance, because typically encryption is pretty a heavy operation and computational intensive. And this is true. It works relatively slow. On the server that I used for testing, the encryption is as slow as 1.3 million rows per second. However, in many cases, if you have some empty strings, for example, then we do have a code which is optimized already. And for empty strings, the encryption performance is much faster. But keep in mind, if you're using those encryption functions, that it's going to be quite slow both on encryption and decryption. Probably in the future, we will consider some sort of block encryption, and in this case, performance can be significantly improved. Next thing that I would like to discuss is the development in terms of insertions that are going on right now. The first thing that has been added quite long ago in 20.3 version is compact parts. What is compact parts and how it's different from wide part, which is a default ClickHouse way to store the data? The wide part, and this is how ClickHouse stores data by default, it stores data in columns, and every column is stored in at least 2 files. One file for data and another file for index marks. The compact format, it stores all columns and all columns all together in a single file, but it still preserves the columnar structure inside. What it gives you is that amount of number of files is significantly smaller. For example, if I have 100 columns in my table, then it will require 210, something like that, files in order to store a single part. But if we go to compact part, it's only 8 or 9 files. It's significant difference, and especially important if you insert, if you do frequent inserts with small data. Traditionally, you had to use buffer tables in ClickHouse, but with compact parts, it's not longer necessary, or necessary, but in a less extent. This was just a first step, and the next step was memory parts that has been added at summer. And memory parts, they allow ClickHouse to store data in memory in some different format before storing them in disk. So if you insert, then you don't need to wait until the data is written and so on and so forth. And insert performance in terms of frequency, how frequent you can generate insert, increases. ClickHouse has settings to control which data to store in which part. So the smallest inserts may be stored in memory, while they go bigger or they merge it to bigger parts, they may be stored in compact parts. And once the data grows over 1 megabyte, for example, then it's stored in a wide part. It's interesting that if you deal with object storage, this is also makes a lot of difference, because on object storage, for example, it's very expensive to store multiple files, much more expensive than on block storage. But at the same time, it's much less expensive compared to compact part is to read data from small files. For memory parts, ClickHouse also have a write-ahead lock, so it's not unreliable. Unlike buffer tables, if your server crashes, the data is not lost, and when server is started up again, the data is replayed, and you have all the data intact. Certainly, I'm not sure if it's replicated from memory parts or not. This is probably a question to Alexei. Yeah, it is. So then that's all good and we're safe. But this is not enough. Let me show some ugly test that I did quite long ago. And this ugly test shows how fast you can generate single row insert. So if you looked into what I'm doing here, I'm inserting into test table some numbers, but I set max block size to 1, and that generates me one row blocks, and every row is inserted separately. And as you can see, when we go from left to right, from traditional wide tables to compact tables, and then later to memory tables, the performance increases. Certainly, in reality, it would be a different extent, and I would expect that performance of insertion to memory table, especially if you have a lot of columns, should be order of magnitude faster comparing to a wide table. Not performance, but frequency, how fast you can insert the data. But it demonstrates that this functionality works. But this is not enough, and in a very recent version, we have a new set of features that allow ClickHouse to write data to disk and make sure that data is written. Because by default, if ClickHouse writes data, it doesn't f-sync because it takes time, and it's done for performance. That's why ClickHouse can insert data as fast as possible. But if your server crashes, then you may lose some data, potentially. If you have replica, then the chance is lower. But if you don't have a replica, or your replica is in the same availability zone, and you have some power shutdown everywhere, then you may have corrupted data. So in order to prevent that, ClickHouse now have all sort of settings to control when you want to do sync. I don't know a lot of detail about that, but I think this is important. Alexei, do you want to add something?
I can do it, but I have to explain it very carefully.
Sure.
Because people often just don't understand what are the consequences of specific particular settings of file system or operating system, or what depends on hardware that they use, or what depends on configuration of RAID controller. What is the difference in practice between software RAID and hardware RAID controllers? It's a big topic. If you want, we can break for 5 minutes and I will show some links and I can explain it in great detail. But maybe it's better just to continue and I will explain later.
Okay, if there are questions on this topic, we can dig into a deeper dive. Okay.
Okay.
Next interesting thing is TTL extensions. As you may know, TTLs originally appeared in ClickHouse more than a year ago, and it was TTL for data dropping, originally dropping some old partitions as the time comes, but later on, the functionality and syntax has been extended to cover more use cases. The first extension was adding TTL moves that allowed ClickHouse to move data between different storage tiers. So you could and you can store some data on faster storage, and as the time goes, for example, the data which is older than 1 month, you can go to some more affordable storage device. The next set of extensions has been added in 20.45 version back in May, and it allowed to add extra where condition, TTL delete where, so it drops not just the data that matches TTL expression, but also extra condition. For example, you may not want to store some user identity older than 3 months, but you still want to keep the data, even anonymized for marketing purposes. TTL group by is another interesting extension that we actually showed at our summer webinar, and I don't have an example here, but it allows you to do roll-ups after a certain period of time at the same exact table. So you can consider that your recent data, like for example 7 days of data, is stored without any aggregation, and then at the same table you aggregate data with our granularity, for example, and after 1 month you may even aggregate data daily, and this is all happening at the same table. So it's TTL group by. And the latest feature to the gang is TTL recompress that has been added just recently, and it allows you to recompress the data which is old. ClickHouse always had an option to configure different compression depending on part size, and the idea was that when your parts grow, they grow as the time goes, and some bigger parts you can compress differently, for example, with more aggressive GSTD level. Right now, you can configure it explicitly and at a table level. You can specify that the data after a certain time is compressed by GSTD1, and later, after 1 year, you apply even more aggressive compression. The logic of TTL is the same. The only difference is what action ClickHouse applies as the TTL expression goes through. Next feature, I actually discussed it today. This is very new for me as well, but I was motivated by a customer use case, and I will show you in the next slide. So when I discovered this, I immediately recognized that this is a very cool feature and has a good potential, and I will show you in a minute why. So what this feature allows you is to define your custom settings, but more importantly, use those custom settings in query. This is performed using getSetting function. So you can specify, first you need to enable settings in configuration, and you can have multiple prefixes. And second, if you set a certain custom setting, and you can do it in a session, you can do it in a user, in a profile file, then you can query the setting. It sounds not very cool, but what it allows you is to do parameterized view. You can create a view which uses a parameter and use this parameter in a session. So you have a single view. This is certainly an artificial example, right? In a real life, I would probably not to do that, but imagine that you have a view and you need some parameter to use quite often in this view, not in a single place. Or imagine that you want the view to return different results for different users, and you want the behavior to be configured using this parameter. By the way, if you want to limit users to some particular data, you may use row level filters, but this is more generic thing. So, and this is an example how we can use it. So you first define some custom setting, and then you can use the setting in a view when you create a view, and later on in every session you just set different value for the setting and run a query for the view, and you get different result for different users. I think this is a very cool feature. And next, this is kind of funny feature, but I really liked it when I saw it first time a few weeks ago, and I already used it several times when I needed to copy data from one table to another, but not all the data, but not all columns, but just a subset of the columns. The columns kind of meta function, because it's a function which is not a SQL, but on a level of query parser. It allows you to return columns that match regular expression. So when I specify select columns and customer in quotas, it will return me all columns, not rows, all columns that have customer in this name. In addition to that, and this is addition in 20.9, there is accept function that allows you to do negation. I don't want customer ID column, for example, from my table, or I want all columns except customer ID. It also works. And even more, in addition to accept, I can also use replace function that allow me to replace column with something different. It may be a constant, like in this example, I just hide customer name with a hidden string, or it may be expression on this column. This is also possible. Kind of cool, but it's not only it. You can also do apply, and you can execute apply multiple times, and apply applies certain SQL function. So we started from some meta functions, and now we apply SQL functions to a column. So this example, which is shown, will get all columns that have customer. Then it will apply toString to them, convert them to string. Then it will apply length, so it will calculate length of all column names, not column values, but column names. And after that, it will calculate the maximum length. So this query will return me maximum column length of all columns that have customer inside. Again, this is a weird example, but this is a real one. So in a single query, I can return all columns that have bytes. And as you know, ClickHouse uses it in system parts in order to calculate different sizes. So if I would write, if I want to write a query that would return all 6 columns, the query would be much not as compact. But with those column transformations, I can do it very easily in a very compact way.
Alexander, you've got a question that came up from the previous setting or
Yep.
previous section on custom settings.
Mhm.
If it's if you want to just address this, could custom settings evolve into session variables?
It is almost a session variable already, right? So ClickHouse doesn't have session variables, but every setting, it can be overridden on session basis. So you can consider inside the session that it is a session variable. But at the same time, you can set a global value as well, right? But override on a session level.
So if it is not a session variable, what it is?
It's just it's a setting, but you can override it on a session level, like any other setting.
You can override on session level, on query level, on user level, on profile level.
I think it's more powerful than session variable.
What to put it in context, because this is something I've kind of missed, is how do the semantics of this differ from MySQL? Because I think MySQL did a pretty good job on global and session variables. How much of it can we get everything in ClickHouse that you can get in MySQL?
Yeah, you can get everything that you can get in MySQL, but you can get even more because you can define those variables and supply values inside user profile. So consider that you have a custom variable, something like a team or whatever, and you can set it in a user profile if you wish to. And it will be enforced for different users automatically by ClickHouse. But on top of that, you can also define it in a session as well.
Great, thanks.
Okay, but that's almost it. But there is much more. This is something that we're also very interested in, is cluster usability improvements. And this list is probably not complete. This is what I added from the top of my head. Alexei may have some other additions, but a few usability improvements that have been done or are in progress. Starting from system drop replica, which allows you to forget that replica forever. Then we're currently working on system restore replica that allows you to restore a replica if you lost Zookeeper. I'm pretty sure that everybody who worked with replication has lost Zookeeper at least once. And you know that if you have to restore the metadata in Zookeeper, it's kind of painful process. So system restore replica should make it much easier. Next feature, which is currently in progress, is database replicated. And we at Altinity actually expected and want it a lot, and probably folks from Yandex Cloud as well, because it allows you to define your replication properties once on a database level, and after that you just create tables without specifying these Zookeeper paths, etc. It is inherited from database. Let's put it this way. Also, as you know, ClickHouse doesn't support automatic load balancing, and we were discussing that a lot of times, how to do it, and even have a plan. But folks from Cloudflare, they started to do it on their own. So there is a plan that you can, or architecture proposal that you can read in GitHub. This is PR number that you can see right now, and it's already started to be executed from different directions. Certainly, it's a long project, and we're not sure about the result. But given that Cloudflare is a very active ClickHouse community company, and they have very smart people, there is a good chance that they will make it to work. And a few other things that in our kind of to-do list is easy conversion from replicated to non-replicated tables. Actually, from usability perspective, it would be much easier if user wouldn't care about if table is replicated or non-replicated at all. We just create a table, and if cluster has a replica, then table is replicated. If cluster doesn't have a replica, then table is not replicated. And this is only difference. But once we get there, it will take probably a couple of years. So now we think of a tool or a SQL command that will allow you to convert table from replicated to non-replicated form on a SQL level. And last but not least, and Alexey will probably give an update on that, is how we can write or insert to ClickHouse if Zookeeper is not available. It wasn't possible for a long time, but now after certain changes in how replication works, it's going to be possible, and the behavior that we envision is the following. So if your Zookeeper is not available, it may be down, or you have some network partitioning or whatever, then you can continue to insert to every replica independently. Certainly they cannot replicate to each other, but they continue to accept inserts, they continue to merge the data, the new data, only the new data that has been inserted, and when the connectivity is restored or Zookeeper is up, they will replicate back and forth the data that has arrived since then. Alexey, is it something that we will get soon?
Yeah, totally right, but not soon. Not soon, not this year. Next year, probably. Most likely.
Okay, thank you. And last, ClickHouse never stops to improve performance. And from Altinity side, we contributed with small feature, but quite important. We added optimization of low cardinality arrays. So if you have key value arrays, then up until recently, ClickHouse, even if you store a low cardinality, if you use low cardinality types for keys, for example, ClickHouse couldn't use it efficiently. And now it can. So starting from 20.5, arrays are much faster to access using index of, has, and functions like that, if you need to search for that something is inside the array. Another important change is respectfulness to monotonicity of index columns, and it's a little bit math term, but it's very important for index searches. So if you have a function on the index column, and if this function is monotonic, then it doesn't change the order of the data on the disk. So you can consider that if the data on the disk, it's always sorted by our key columns, right? And if you have a monotonic function that the sorted data is sorted by this monotonic function the same way as by original one. And if ClickHouse respects this fully, then you can safely apply all kinds of functions like toDate time, any sort of truncation ones that are monotonic, and that will still use the index and primary key effectively. And in addition to that, you can see quite a long list of different settings that are currently, that has been recently added in ClickHouse for different sort of performance optimizations. I think they are disabled by default. So in order to try the effect, you need to enable them because all of them are kind of experimental. But they were added for a reason, and they improve ClickHouse in situations when you need to get the best performance, and you know that your data is, you know your data, and you know that the use of such a feature can improve the performance. I think that's it for the intro part. Robert, do we have any questions that we need to answer so far?
Yeah, we do have a question, but it's actually related to ClickHouse Operator, which we'll get to in just a second. I think at this point, we can open it up to questions if you want to, put them in go ahead and put them in the chat box, or if you want to ask them directly. I think you should be able to raise your hand. I can't see that control, so I hope you have it. And then I can unmute you and we'll let you talk. In the meantime, Alexei and Denise, do you have any other things that, sort of interesting things from ClickHouse that you'd like to bring up that you think that people in the community ought to know about?
So, Alexander, how did you forget about explain query?
I actually didn't forget about that, but I never use it because I prefer trace. That's why I don't think it's really important.
But I hope you will get used to it soon.
Yeah, I will try. Yeah, speaking of other functions, other features that we may mention is materialize MySQL database engine is actually very interesting, but I see still there are a lot of bugs in there. That's why I don't want to tell a lot about that. The idea is great. It just allows you to replicate MySQL to ClickHouse in real time. And we did it in Altinity with some external tool some time ago, but native support inside ClickHouse is certainly much better. So we will see once this feature stabilizes, and then probably folks from Percona will start testing it and write some good articles on this topic.
So this feature is highly experimental,
yeah,
but also highly appreciated. So if you feel you like experimenting, you can try, but probably not in production.
Right. Denise, do you have any that are, stick in your mind as sort of interesting things you've seen recently that you would highlight?
Maybe then Sasha explained about optimization. Actually, I recollect that Amos improved partition pruning a lot, and actually I wrote a test for this improvement, and I tested various scenarios, like 100 queries probably, and everything I was able to imagine, actually it was use pruning, so it's kind of amazing what he did, and right now actually he is doing more, so pruning is improved a lot. I like it. Yeah.
Could you elaborate what didn't work before? So it's also something about monotonicity, right?
Yeah, it's like now you can do anything, like to write to in div from something by 1000 plus 1 minus 1 equals something. I don't know. It's easier to see my tests and understand what he did. Actually, everything. Yeah, it's all monotonic functions actually proving to work for them now.
Yeah, that's good news.
So it's very surprising actually, because Dennis has tried everything he can imagine, and everything works.
Yeah.
Right. Okay. I think we should go ahead and open it up for what you've all been waiting for, which is you all get to ask questions about anything you want. If you're listening on YouTube, go ahead and type them into the live chat. We're monitoring that. But we've got a couple of live ones here related to Kubernetes. Let's start with an easy one. Is it possible to run ClickHouse in Kubernetes? I think that might be a question for Alexander.
I think, Robert, you can answer this as well, but yes, it's possible.
Answer is very easy.
Yeah.
Very
yes.
Simple. Yes.
Yes. I was giving it to Alexander though, because it cost him I just use it. Alexander actually took care of making sure it works. So do you want to talk a little bit about the ClickHouse operator? Because there's also a follow-on question about how to get it to not deploy the public load balancer.
Yeah, sure. First, all examples all query examples, probably except a couple that you have seen in the slides, they were running, they were executed on ClickHouse running inside Kubernetes. Right. So we use ClickHouse in Altinity. We use ClickHouse on Kubernetes all the time, and actually, right now we probably don't have any ClickHouse that runs outside of Kubernetes at all. And this is not just us. If you were watching our webinars and meetups, eBay is running a huge ClickHouse cluster inside Kubernetes. How they do it and how we do it is very simple. We just developed this ClickHouse operator, which makes ClickHouse management and operation inside Kubernetes is an easy walk. Probably not as easy as you can expect, but literally you can start ClickHouse server with a YAML file of 4 lines, and that's about it. And you can go and extend it, add in shards, replicas, and that will be another line. So actually in 5 lines YAML file, you can start ClickHouse cluster of 100 nodes if you wish, because it's Kubernetes. It's as easy as it is. But certainly you can also configure everything you need. And if you go to production deployment, there are many things to worry about, such as how you manage your storage, how you manage your affinity and anti-affinity rules in order to make sure that your deployment is reliable and ClickHouse pods are located where you want them to be located, and so on and so forth. But generally speaking, this is certainly a great and a very interesting way to run databases. Sometimes people say that Kubernetes is a new Linux, and we all have to adapt to this paradigm. And it's not just ClickHouse. Many open source databases, they also have ClickHouse operators. For some of them, there are many ClickHouse operators available from different companies. For example, for MySQL, there are probably 3 good ClickHouse operators from different vendors. For ClickHouse, there is only 1 so far.
Okay.
Sasha, I have a question about a year ago, I remember that you mentioned that in presentation, you mentioned that network performance is not so good in Kubernetes, and you are going to improve it. Did you improve it?
Yes, we actually, it was not an issue with Kubernetes network. It was more an issue with how you configure network in Kubernetes inside some other public cloud, because certainly some companies are running bare metal Kubernetes, and in this case they just use sometimes even host network, and a network overhead is 0. But if you go to the public cloud, the network stack is more complicated. You have your Kubernetes network overlay, you have something on AWS or Google side, and so on and so forth. So what we did is we actually first we moved from application load balancer to network load balancer, which is level 4 at level 4 of IP stack, and that gives good improvement for output and reliability in general. And now we even go into to use ingress controller, custom ingress controller, in order not to use whatever public cloud provides at all. So all, putting it short, all network problems are coming from outside, not from Kubernetes itself.
Okay, cool.
Speaking of network, there's one last question which I can just take. I'm using the ClickHouse operator installation in AusEKS. Is there a way to stop ClickHouse from deploying the public load balancer and deploy an Aus elastic load balancer? The answer is yes. Actually, you have a lot of control over the load balancing, and because you're basically but what you have to do is write a service template when you're configuring the ClickHouse operator and writing your custom resource definition. There are examples of doing this in the source code for the ClickHouse operator has a bunch of example YAML files. You can find them in there, but I can tell you from personal experience, you just have to try it a few times and eventually you'll get it right. You can definitely switch between different load balancer types and you can shut them off entirely. So, but you do have to understand how services are configured in Kubernetes itself. And then you have to try it. The settings, this is a place where Kubernetes is not super consistent across distributions. So you'll definitely have to try it in your distribution and make sure it works. So that's all I can say. Unfortunately, it's not well documented. If you do figure out how to do something, I'd really recommend filing an issue on the ClickHouse operator, and we'll make sure it gets documented.
Yeah, and also just to add to the documentation topic, I don't know if it's the right time to tell about that, but we're looking for somebody who will help us with documentation.
Yes, if you're good at it and want to work on this, give us a call. And of course, Alexi's team at Yandex has done a really magnificent job of doing the ClickHouse documentation, but I think we all know that we can do more. So we're also seeking a doc person. Let's go to questions. Go off Kubernetes. There's a bunch of questions about ClickHouse itself. I'll just take them in order. So first one, do you have any updates on analytic functions and window functions? Might be an Alexi one.
So this task is planned for year 2021. And currently, we only have prepared some internal infrastructure for query pipeline, but did not even start to develop the feature itself.
Hey, I have a follow-on for that, Alexi, which is, if you look at arrays, is there anything in, like you compare arrays, say, to window functions? I know it's a different, very different syntactically, but often ends up at the same result. Is there anything in window functions that you know of that cannot be done now in arrays?
Most of what you can imagine can be done, but some of things can be only done in very difficult and natural way. This is related to rank calculation, for example. Ranks inside Windows.
Okay, so the key is that there is, like, you can do this stuff with arrays, but you may end up writing a lot of code with lambdas and sort of array functions, sort of cascading.
Yeah. And actually, I don't feel happy looking at the queries that some users of ClickHouse tend to write.
What is the source of your unhappiness?
It's very usually they are very complicated, difficult to read, and I cannot imagine that even I can write these queries. But users do it.
Yeah. Do you remember the query that I sent you sometime? 500,000 kilobytes. 500. Yeah, 500 kilobytes. Yeah, that was.
I even have a collection. It's a private collection. I will not show you. That is named the Golden Fund of ClickHouse queries. The most weird, unusual ClickHouse queries that ClickHouse can execute successfully.
Okay, great. Good. Next question. Are there any plans to support full text search? And I mean this not as a replacement for ELK, but more like a specific BI search on some text.
So it depends on what text do you consider. Is it a text on natural language and you have to apply some transformations to your queries, like word stemming, word normalization, what every real natural text search system has to do. And for this task, we consider it as experimental task. experimental task for this season year 2020-2021. But if you consider another task of text search, if, for example, you have some machine-generated data and you have to do some log analysis, you usually don't have to bother with the text normalization. You can just search as is. And also, you usually don't have to bother with the full text indexing because you just specify some time period for log search. And you only need to scan this period as quick as possible. And ClickHouse can do it. ClickHouse can do it right now because the text matching functions that we have, regular expressions matching, simple like substring matching, case sensitive, case insensitive matching, multiple regex matching, all these routines are very heavily optimized.
Okay, great. Let's see, another question. Oh, here's a good one. We'll go ahead and do this as this might be a good one for you, Denise. What are your main recommendations for batch loading files as quickly as possible into ClickHouse? Formats you would recommend? We recently did an unscientific test and Apache Arrow came out as a strong contender. Are there other levers?
I don't know. I think that ClickHouse client make it faster.
But what format?
Yeah, you can use probably Parquet. Something will be the best format for this.
Mm-hmm.
Sometimes it depends on what cost it will take to prepare data from your application in this format. Because ClickHouse can load data quickly, even in CSV, TSV. You can look at the binary format, and processing of ClickHouse binary format will be much more efficient for ClickHouse. But you can struggle to format this data in this format from your application. So you have to decide.
Yeah, you know, Alexei, that brings up an interesting topic which that we discussed recently, you know, sort of at, you know, in one of the community meetings, which was how to be more flexible in, you know, being able to ingest data, for example, where you don't even have a table schema yet, and you know, create the table schema automatically. And for those of you that are hearing about this for the first time, the idea was that, for example, if you're reading JSON, it would be awfully nice if, in simple cases at least, you could just look at the JSON and say, hey, that's a string, that's a number. Let's just make a base table that's as close to, you know, that's as close to the data as possible and pop it in. Do you want to comment on that and sort of other innovative things that you can think of that may be in the roadmap for as far as interfaces?
But there are two different questions. First question is, what format is the most efficient to load into ClickHouse? And another question is about developer productivity. And what you are talking about is developer productivity. If you care about efficiency the most, you have to carefully define your schema of your tables. It's unavoidable.
Mm-hmm.
If you don't care, you can just load every JSON as a single field of type string, and then parse this JSON by creating another materialized columns or by insert select into another table. And about schema inference, this is in the list of experimental tasks.
Yeah, so if anybody likes that problem, oh, go ahead, Denise.
Yeah. About table creation, you actually when you create a table, not only columns and types important, but also partitioning and ordering the data. So actually, it's if you choose right sort shortness for data. The data will be compressed a lot, and it will speed up region a lot. Yeah. So and it kind of hard to guess the right order of the data.
Right. So,
and my recommendation, please don't play too much with partitioning. If you will make too high granular partitioning, it will most likely just degrade performance.
right. Right. Yeah, it's an interesting and kind of muddy topic. So, but I just brought it up because as Alexei says, it is a developer productivity issue, but we see a lot of use cases where people are just beginning to use ClickHouse. They have some data and we'd like to enable them to get a bit of data, sort of data in perhaps a not so great format, but in ClickHouse where they can then start playing around with it and optimizing it further. So it's definitely something that's going to be on the roadmap. Let's see. We have, here's a subject that I think you've heard before. There's a PR that tries to add etcd support for ClickHouse cluster as a replacement for Zookeeper. It looks like the attempt is not successful. What's the blocker? Is it architecture-driven incompatibility or anything else? How hard would it be to add support for etcd?
Yes, the issue looks like to be architecture-driven. I can explain. It depends on the semantic of watches in etcd. You cannot, if I remember correctly, maybe there will be some mistakes, but if I remember correctly, you cannot atomically change or create a node and assign a watch. And you have to first assign a watch to non-existing node, then create it, then receive all events and filter these events based on whether the node was created or not. And actually, there are multiple differences in the semantics and data model in Zookeeper and etcd. And currently, this task is questionable. A colleague from my team is currently investigating. Is it possible to even make it correct? After we will make it correct, there will be another question. Is it possible to make it to work reliably and efficiently? And this is also a question. So don't expect too much, but currently we also have another task that is named provide embedded into ClickHouse alternative to Zookeeper. And this task is way more perspective.
Can you talk a little bit about that? Because I think that from my perspective, that seems like the natural thing to do is not to support etcd, but just get rid of the external consensus management entirely. And maybe you could comment a little bit about how you see that, both what that would look like and how you see when that might appear if it's possible.
So the most important are motivation points, and there are quite a few. So first, you don't have to have extra dependency and extra separate servers. So if you use ClickHouse in a cloud, you don't have to bring 3 additional small virtual machines specifically for Zookeeper in addition to ClickHouse. We want to make it to work within ClickHouse itself. Another consideration is some details about Zookeeper itself. For example, Zookeeper has global transaction identifier that is just int32 number. And there are multiple clients where this transaction identifier just overflows every a few days. Zookeeper just restart, tables become read-only, and there is a few minutes when inserts are unavailable. And usually it is fine, but how to fix this issue? This issue is unfixable in Zookeeper, but we have to do something about it. And there are also multiple points. For example, snapshots are stored on disk uncompressed. That's not efficient if we have snapshots for tens of gigabytes, and this is quite common on our clusters. So there are multiple points.
Yeah, and I have to say that the point you made about the cloud operation is an interesting one, since both your team is supporting Yandex Cloud. We're also operating our own cloud, and we see exactly the same thing. And I think everybody else that runs this in a cloud sees the little 3VM problem that we'd all sort of like to get rid of as we spin these things up. Let's keep moving. We have another question. I think it's a little bit of an overlap, but hey guys, thanks for the great job. What are the plans for Windows aggregate functions development? I think we covered that. Here's a good one though, and maybe for pivot and unpivot. Any comments on that one?
So about window functions, this is one of the big tasks for the next year. And about pivot and unpivot, we don't have it inside ClickHouse, and currently we did not even consider implementation, because usually you can do it inside business intelligence tools. So you receive just a usual table from ClickHouse, and you do pivot and unpivot on top of it. But probably we should consider.
The problem with pivot and unpivot that actually SQL relies on that idea that you have knowledge of columns and column types before executing the query. So IDBC and some other tools, they actually do like prepare query and they get the column structure before query execution. But for after the pivot, you have actually another column structure. So it's kind of I don't know actually SQL databases which allows you pivot and gets like arbitrary column set for each row. I don't know.
Yeah, I think that I know that to Alexi's point, when I have to do a pivot, I just pull it back into Pandas and do it there because Pandas makes it pretty easy. So, okay, great. Thank you very much. Let's see. Next one is the live view feature still experimental? And how do ClickHouse developers feel about this feature? Alexander, you want to comment on that one? I know that there's at least one developer who really likes it.
Yeah, I think a live view feature is still experimental, but we encourage anybody to start using it and report any problems that you can find. So we know of some of them. In particular, I don't remember if we fixed the behavior for distributed and replicated tables completely. There are probably some corner cases here and there, but in general, this is a feature. The feature is very interesting, right? So we all every time we tell people about that, they say, "Wow," but I don't know if anybody uses it in real production yet.
The person who wrote this, Garrett, if you want to if you do want to go live and expand more on how you're using it and what you'd like to do, I can unmute you. Just go ahead and post a chat message or raise your hand if you can. Okay, great. So next one. Here's a good one. We get this a lot. So as far as I recall, the documentation says ClickHouse is not designed for high queries per second. I wonder, apart from the execution model of a distributed query and hardware limitations, which is to say cores times replication factor, what would be the constraints to consider?
So, Alexander or
Alexei? Yeah, you can answer.
When you talk about high QPS, it's a question about What actually does it mean, high QPS? Is it hundreds queries per second or hundreds thousands queries per second? ClickHouse definitely cannot work for hundreds of thousands queries per second. It's more like a scenario for key value databases, when queries are very simple each, but you have to process a huge amount of these very short, simple queries. But ClickHouse is different. A query, single query, can process billions of records, sometimes trillions of records. This is also real. But I am definitely sure that you cannot process thousands of queries on single server per second. Each of them process billions of records. It will be just hundreds billions of records per second. And this is actually doable if you have a cluster of appropriate size. And if you distribute data on top of this cluster in a proper way. So what are the considerations if you have some moderate or high QPS scenario, like thousands of queries per second? What will be the choice of your cluster configuration and hardware configuration? First, if you have multiple short queries, you have to ensure that the working set for these queries is fit in memory, or at least you have high-performant SSDs. You don't have to fit all your data in memory, but usually frequent short queries just touch only a small subset of data, and ClickHouse and operating system will figure out this subset. And if the amount of memory is enough, these queries will be served directly from memory. And you will be able to support higher QPS. And another very important consideration is the configuration of your cluster. Suppose you have high QPS, but it will be completely different if every distributed query will go to every server, or you can distribute your workload so every query will go only to one or a few servers from a cluster. Then QPS, maximum QPS, will just sum up. So it's quite a big topic to explain, but
yeah, and we also had a couple of articles, ClickHouse under the storm. If you search in Google, that try to measure the maximum possible QPS scenario from ClickHouse server when everything is in memory and different access structures are used. And I think we got something like 4,000 per second.
Yeah, it was pretty much how much can we abuse ClickHouse? We have a like what? Michael, he was not very nice to the poor ClickHouse instance. Next question. So I hope that helped. It's a very, as Alexei says, it's a very general question. Here's a question: what are interesting ClickHouse tools that are coming soon? And I think there was a might be a good time. There was a PR that caught our attention, which was for a UI for ClickHouse that got merged. Maybe you can talk about that and any other interesting tools that you see, Alexei.
Yeah, I can show you this UI, and also I can show you some other interesting tools, just a few that I remember. One moment. So about ClickHouse UI. This is very simple and easy to use and lightweight UI that is embedded directly into ClickHouse. So just type an URL and you can type just play. Here is the query. Just type run or press Ctrl Enter, and the data will be instantly available. You don't have to install anything. It is available on every ClickHouse instance. And the most important is the general sense of speed and overall lightweight feeling. This is the most lightweight and easy to use ClickHouse UI that ever exists. Yes, and it includes light and dark theme, as you like. And about another interesting tool is ClickHouse Query Obfuscator. So suppose you have a situation when your client tells you that I have a query, but this query is does not execute successfully or not performant enough, and you just say, show me your query. But your client said you, yes, I have this query, but it contains some fields and some expressions from our domain area, and my managers did not allow me to share this query. So how he or she can share a query to you so you can look and tell what to optimize? And the answer is a specific mode of ClickHouse format that is named Obfuscate. It will transform all column names and all constants. So these column names and constants will continue to look very natural, but they will be completely different. And actually, maybe this client have domain area of just web analytics or clickstream analysis, but after it is transformed, it becomes actually very mysterious. Very mysterious because it is very strange domain area. Like what is Rain Headphones Mentor or Eternity Rain Risk. So it's very interesting table. And constants are also obfuscated. If constants were in Chinese, it will remain in Chinese, but it will be some gibberish Chinese. I don't know. But the query continued to work. Table structure also transformed. You can reproduce the issue. You can read the query and say, you can say that this query is quite optimal. So you did a great job. Thank you. So do you want some more interesting tools or?
Yeah, also probably worth mentioning normalized query function, which is really cool for query log analysis.
Yeah, for example, if you have a query log and you want just to group queries by their classes, by their kinds, regardless to the values of constants. There is a function in ClickHouse, just normalized query and constants will be replaced by question marks, and also the lists of constants will be replaced to some other replacement.
Okay. Denise, any tools from your side that you've seen pop up recently that you would point people to?
Microphone.
I think you're unmuted, but I think I saw you saying no.
No.
Great. Hey, speaking of microphones, Garrett, I'm going to just go ahead and unmute you. So, Garrett, welcome. You should be able to unmute and tell us a little bit more about what you're doing with live views.
Yeah. Hi. Yeah, live views is something I've noticed in ClickHouse that I find very interesting, to be honest. I've worked with databases also my whole life, and I've always worked with MySQL for some reason. I did see a bit of pub/sub features popping up in databases like Postgres and so, for example, but there's no sign of this in MySQL yet. And currently we're facing relatively small data set problems, like, for example, 15 million vehicles that are registered, officially registered in Holland, where we have to process these 50 million vehicles and find all the changes in the data set. So only the mutations are basically being sent and being tracked. So somehow create an audit log of a static set of data that we only receive. Now it's once a day, but it's going to be once an hour now. And so ClickHouse is, well, it's a dream to work with ClickHouse, insert this data and play with it. But we build our own solutions to, well, basically use ClickHouse to insert the data, and then we basically keep inserting in the same table, the same data, but then have some kind of version number with every batch, which we also found a way to, instead of inserting all 50 million rows and have to wait until the last row is done, to start checking immediately. But it's all code that we've written outside of ClickHouse. And when we saw live view, we were like, hey, this is an interesting feature. If you could write some queries towards the same data set, because once the data is, let's say, committed to ClickHouse, that it's available for other queries to pick it up, well, maybe live view would pick it up, and then we could use that as a trigger, for example. So, for example, when we increase the version number, we say, okay, now this is let's say 10,000 rows, and we want to increase the version number. Well, all we got to do is start inserting new data, and the live view will say, well, what's the max number so far, for example. And but we saw that live view, well, seems to be struggling with certain, well, the variables is now a very interesting case. So I was wondering, for example, would variables work in a live view as well, if it wants to have sub queries? So inside the same query, it tends to not pick up things or so. I'm not really sure how live view works, and because it's experimental, I don't really want to base our product on it yet, but I find it a very interesting concept which has a lot more potential than it has right now. So it was funny to hear that I seem to be the only one using it.
Well, the developer I was talking about is actually Vitaly Zakaznikov, who is the guy that wrote it. And he wrote it for managing tests and tracking them. I guess one question about this is, from what you're describing, why would a materialized view not work? Because I understand that's another way of treating.
Well, there's still people. So we make it easy for people to digest changes to a data set, which is quite large. And we see this all the time. It's always, the data is always there too late. It's always like, why? Like, for example, just a little explanation of what we do is that we're in the automotive business, and everything that is, so for a secondhand car to be able to be sold, and the consumer basically wants to buy a new car, he will then go to a car dealer. Car dealer says, okay, I want to know what this car is worth right now on the market, compare it to others. You can get all the information from damage history to every possible information there is to know on the market. We all gather that into one database. And the problem is that these original data sets, like, for example, a link between a VIN, the vehicle identification number, and a license plate, for example, is in another database. And all these things are constantly either dumped, like a large CSV or whatever. Then we said we'll start doing TSV because it's a lot faster than CSV, for example, we've noticed. But then, even though we can handle this data, everybody else wants the same technologies. But of course, we love that we have something that other people don't have. But we're trying to then somehow stream this to them in just the mutations. But we end up just dumping dumps again to their servers, which they have to pick up. And we want to start doing this real time. So just be as efficient as possible. And we just bumped into live view, and
yeah,
I thought it could.
Okay,
solve
great.
some of
So
this.
I can tell you that Vitaly was, I think, watching on the YouTube stream and just appreciated the love that you're giving this feature. One other question I have is, would it work to? It is possible from ClickHouse to write out to Kafka. It's not super reliable
Yeah.
at this point, but is that something? Because that's another way to do both ingest and egress of notifications and events.
Yeah. Yeah, of course. There's other technologies, but yeah, we just love to keep things as simple as possible. And it's funny that these queries were shown, these large queries, Alexi or what showed. Yes, it can get like that, where it's really like very cool to just have one tool that does it all basically, or does a lot for you. And so this is why we were looking at live view. Currently, of course, we just use PubSub mechanism, but I like the idea of being able to store all the data and somehow replay this data and say, like, look, this it's almost like having Git, for example, for your database. It's like being able to go back in time and recreate a set the way it was back then, and know what the differences are. So if you bring that a little bit further, you can literally have somebody querying data now and give him the mutations, the patches he should have to make to his data set. If he was to, for example, have a JSON object of this data, then you could literally give him the patch basically so his object is up to date again. So, but this is all stuff that we're looking at when front-end developers, because they want GraphQL or they want all these different ways to get data. And I'm just looking at a language that is a query language ultimately. So going from GraphQL, for example, to SQL basically. And I love all the features that ClickHouse has, especially the array features and so as well. So you can really get a lot done in ClickHouse and almost have the exact result that you need for the end user, let's say. So we were just going on with that and say, like, well, if you could now give that into a stream with then where they could easily say, like, well, okay, I lost connection, so I'm going to have to like go back, and I was here, so let's replay all of this. And this is all possible with ClickHouse. We've noticed.
Let me suggest something, Garrett. Let me suggest something. So Vitaly is listening to this, and very interesting. He can't talk because he's on the stream. But yeah, why don't you do the following? I would suggest you post your example. You can post it in the meetup, and we'll catch it there, or you can go ahead and post it as an issue to ClickHouse. But it will definitely, if it's marked as live views, it'll end up in Vitaly's queue. So, and he's definitely interested in looking into it and appreciates you thinking about this feature. I'm going to keep going because we have a few more. Vitaly and Alexander, I just want to make sure that we're not going over time for you guys. We have about 6 more questions. I figure we can keep going if you guys are game to keep answering them. I just want to make sure we're not. Alexi and Alexander, you guys are okay to keep answering questions?
Yeah. So
I know it's getting late for you.
I answered a couple, but
we've got one here. We've got one here from Stefan Pham. I'm using ClickHouse, Kafka in front of ClickHouse. My application pushes data in Kafka, and then ClickHouse consumes the Kafka topic with Kafka Table Engine. Is it better than sending the data directly to ClickHouse? The issue is when we need to alter the Kafka table, we have to stop consuming to alter the schema. Does anybody want to take that one? I guess actually, let me go ahead and Stefan, if you're on, here, let me just go ahead and Stefan, I've just unmuted you. If you want to, here, you should be able. Oops, got one too many here. Stefan, if you want to go ahead and unmute yourself, you can just explain a little bit more about this, because my first question is what's the problem with stopping the consumption? Because you don't have to do it very long to do metadata, to do query update or to do table updates. I'm just curious why that's a blocker.
You don't need to stop consumption on a producer. You need to stop consumption. You need to detach materials the view and change the Kafka table.
Right. And I guess my question is, why is that? Because you can do that really quickly, right? You can do the detach and then upgrade your table and then reattach, and that that you can do in seconds, because at least when I've tried it, it's pretty quick. So that would be my first question, is why that's a problem. So I don't know if Stefan can unmute, but that I guess this is if you have your own application, you can do anything you want, and you can allow them to you can transparently manage changes, but at some level, either your application is going to have to get smart about the schema and know enough to say, either your schema has to be designed in a way that you can add new data without having to do an upgrade, maybe because you do it in the background before these messages arrive, or your application is smart enough to bundle the data so that the record types are not, so there's no visible change in schema. I think you're still going to have to do some work to work around this problem. This is just a basic problem with relational databases reading out of message systems. So
or you can start to write to another topic and create another Kafka table and one more materials to view, and that's all. Yeah.
Okay. I don't know if we gave you help, but that's sort of what we would suggest. Let's see. Is there a way to for data to be distributed and replicated by default without any configuration? And that is a follow-up on the replicated data feature that we talked about a few minutes ago.
So the answer is currently not. You have to configure your cluster configuration. You have to figure out what will be the number of shards, the number of replicas, and you have to configure Zookeeper. The replicated database feature will make it considerably more easy to use.
Yeah, the problem that ClickHouse is very agile, and you can actually create infinite number of different clusters over the same nodes. So if you have like 10 nodes, you can create 3 different schema replication or 4 and so on. So it's kind of hard to create it automatically, because ClickHouse doesn't know your needs.
So what is the actual advantage of not having it by default? Just 2 points. It is more flexible and it is more understandable, actually. If you configure it, you at least understand how exactly your data is distributed.
Okay, I hope that helped to answer that. Another one here, are there any plans to explore GPU-powered query processing?
There was 2 attempts to explore GPU query processing, and actually, honestly speaking, both attempts failed. They appeared to be slower than CPU processing. Maybe we did not have powered enough GPU, but even if we did, it only was supporting some subset of relational operators, for example, full sorting of data. And the practical applicability was very limited. Another point is that actually we compare ourselves to some GPU-powered databases like OmniSci, if you know, and for almost every scenario, ClickHouse on CPU is faster than GPU database. The only exception is complicated join of two big tables. All other scenarios, ClickHouse is just better. But we continue to consider possible implementations on GPU. And maybe eventually we will come up with something really great.
As I understand that the bus between CPU and memory is much wider than between GPU and memory. So it's hard to move a lot of data to GPU. And the problem is in GPU architecture itself, because you need to process terabytes of data. And it's hard to deliver to GPU.
Right.
Yes, that's true. But sometimes you need to process gigabytes of data faster. Maybe for this scenario, it's better to process on GPU. And we will just keep this scenario and probably reconsider it eventually.
Okay. Here's a question that came up in chat. I've been trying out the token Bloom filter index on a text field, and I'm not seeing any improvement in query performance. Do I need to do any string formatting ahead of time? Are there recommended settings for number of hash functions or granularity?
First, I would like to listen what Denise will answer to this question, probably. It will be very interesting, even for me.
Sometimes it's very hard to find the right set of settings, and maybe it's impossible for some data sets. And yeah, there is no right answer. You just iterate and change for different settings and see what is better, what is not.
I would also add that it is important to understand what you're actually looking for. So if you're looking for a needle, right? So for a small subset of data, then it has a good chance that Bloom filter will help you, especially if you increase granularity. So default granularity 1 for Bloom filter is typically not very good. You need to boost it to 100 or even 1000 in some cases. But if you're trying to search a huge subset of your data, then Bloom filter wouldn't help. And probably ClickHouse will even take more time analyzing this Bloom filter than actually applying the logic.
And I would ask, you know, that it wasn't mentioned in the question, but I would ask, what did the logs say? So, because it's possible that the problem wasn't the Bloom filter. In fact, it lies somewhere else. So that may not have been the bottleneck. So anyway, sounds like you got a number of answers there. I hope that helped. Got a couple more questions. Let's see. All right, here we intend to. I like this one. I worked on this for about a decade. We intend to replicate data between MySQL and ClickHouse with our own Kafka connector, trying to support table updates. And by that, I assume. Actually, it might. Okay, let me reread this. We intend to support data between MySQL and ClickHouse with our own Kafka connector trying to support table updates. Do you think this is a good idea, considering that we use non-replicated tables and mutation sync equal 1?
It can only work if the number of updates is not huge. If you only have only a few updates per, depends on the data set. For data sets that you actually can afford to have in MySQL, probably you can execute a few updates every 10 minutes, but sometimes better solutions exist. You can use replacing merge tree or collapsing merge tree by rewriting your updates to inserts of modified records or a pair of records, old and new. And you can query this data with final keyword, or for collapsing merge tree, you can apply tricks with aggregate functions of columns multiplied by sign field. You can read about these tricks in documentation. Also, you can consider materialized MySQL, but it's very experimental.
Yeah, actually, the approach with synchronization from external database that uses this replicated or collapsed merge tree is what guys from Zalando took, I guess. So when they developed their Postgres to MySQL, or Postgres to ClickHouse logical replication.
It is the company named Adjust.
It was for Adjust. Yeah, that's right.
Yeah, the other thing that you can do is, I mean, I worked on this quite a bit, and the way that we used to replicate from MySQL, for example, into Hadoop was we would just have row replication enabled, and we replicated everything out of the bin log, and then it's a problem. You know, we were using, in that particular case, Hive we would just do a sort and basically could basically materialize in the query, materialize the state of the table at any point in time. The MySQL bin log does give you an ID in effect, which will give you, which will allow you to order the records. So there's just a number of approaches, and I think like collapsing and replacing merge tree is definitely the right way to think about this, as opposed to thinking about applying updates to tables. Data warehouses are different from MySQL in the sense that it's cheap to store a lot of data. So you might as well just store the whole bin log contents. That would, unless you have an enormous amount, that would be my approach.
Sometimes it's good to store all data from bin log without replacing, without collapsing, without any updates. And you will get the state of your table for any point of time. Exactly.
And that's what we used to do in Hadoop, because it's just a sort to order it, and then you just cut off the, then you just look at the data at any point in time and you can see the exact state of the table. So if you were looking for time travel in MySQL, the way to do it is replicate everything into ClickHouse, and then you'll have it at the cost of writing a query for it. All right, final question. We've had a bunch here. Is it possible to organize a cluster in a way that tables only live on a subset of nodes, but doesn't require the user to know which nodes? Similar to how Kafka can keep topic partitions on a subset of nodes, but you don't need to manually route consumers to specific nodes.
I don't have a good answer to this question, so let Alexander to answer.
I was kind of expecting that you'll talk about this bi-level sharding approach that you have in Metrica, which kind of allows you to keep user data on a subset of nodes, right?
Yeah.
And the real question is how to do it efficiently and easy. And I think we discussed recently that so in Yandex you have your own way. You probably describe it in a minute, but what you can try to do is to define your mapping in a dictionary and use this dictionary as a sharding function. And then you can insert data to the distributed table and actually query from the distributed table as well. And this dictionary with that is used as a sharding function in a distributed table will actually route your data to a subset of users, subset of nodes. But this is kind of high-level idea that we're working on right now with one of Altinity clients, and probably it will require some changes in ClickHouse to work efficiently.
Okay. Go ahead.
Yeah, Alexei.
Go ahead. It looks like
I treat this question in a different way. So suppose I have a cluster with quite a large amount of nodes, for example, hundreds of nodes, and I want to create a table. I want it to be replicated. I don't want it to be replicated on hundreds of nodes. I want just to allocate some, for example, 3 nodes on this cluster, but I don't care what exact nodes, and I want it to automatically move. Maybe, I don't know, but maybe it is possible to implement with a Kubernetes operator. What do you think?
Maybe, but the question is how we define where data is located.
Mm.
And for that, we need some rules and the way to route traffic accordingly.
Yeah.
Yeah.
And
It's,
you don't have too many options. You can define it using cluster, and this is what Metrica does, or you can do some magic with charging function.
And it's actually a kind of an urgent feature or urgent question in Kubernetes, because Kubernetes ingress resources, that is to say load balancers, are kind of dumb. They really just want to have a bunch of processes or pods, if you will, in the background, and they're just spraying transactions across them without much intelligence. There's no built-in intelligence in the routing. So so being able to actually have ClickHouse understand how to route these things would be very interesting, and that's definitely something that it would be fun to get on the roadmap. We have two more questions. There was one actually from the stream that I only just noticed, so apologies to whoever's listening out there. Does the new TTL recompress extension keep existing codecs like double delta? I sure hope so, because we wrote that one.
Yeah, you can configure codecs in a very flexible way. If you specify codec explicitly for a column in your table definition, you can specify default as a compression. For example, codec double delta and default. And this default will be substituted from your recompression TTL. So you can have LZ4 initially and ZSTD of level 1 after 1 month and level 3 after a year.
Cool. Okay, that's a great answer. One final question then. Does ClickHouse make a good choice for implementing data vault? And I don't know what that is, but maybe somebody in the panel knows what that means. It's in the question out of the chat.
I can try to remember what data vault is. Also, I can try to imagine what it what it should be, but better I will just go to search system and Google it. What is data vault exactly? And sorry for my ignorance. So what is data vault?
Data vault modeling is database modeling method for long-term historical storage of data coming from multiple operational systems.
Okay, I feel that I quite understand what it is. So you have multiple operational databases, and you want all data from these operational databases to appear in some long-term storage that is better for analytical purposes. Did I get it right?
That looks close to what I'm reading in Wikipedia, and then with like tags to show you what the system of record was that it came from.
Mm-hmm. So it looks like a classical split between operational and analytical database, and it is quite popular scenario for ClickHouse, but I'm not sure about the details. It's better to clarify this question. Maybe I will answer completely different questions if I did not get it right.
Okay. I think, given the time, we might just pass on this one, but in general, yeah, you can put ClickHouse, you can put multiple data from multiple systems into ClickHouse, no problem. That's definite. So actually, Cornelius, let's just Cornelius is live here. Cornelius, I'm gonna unmute you. If you want to go ahead and unmute and just explain that. We'll take this as our last question, and then we'll call it a day or a night, as the case may be. Go ahead,
Thanks a lot. Thanks a lot. Really awesome information. Thank you very much. Yeah, so data vault it's a modeling technique, as you've pointed out, and it always looked to me that ClickHouse would be able to support it really well. But yeah, it does rely on a few things. For example, hashing functions. I don't know if ClickHouse supports those. It probably does. And also the very wide table formats that's allowed, or very wide tables, is also really a good support there. So yeah, it's probably a good feature, but unless you know more about data vault, I don't know. We don't know data vault. I don't know ClickHouse so much. So yeah, I can't say so much. But thank you very much. I'll investigate further.
Yeah, thank you for pointing that out. And what I would say is, if you do dig into this and do form some conclusions based on your data, please write a blog article and post it. You can definitely contact us. And in fact, for everybody listening here, if you are working on interesting ClickHouse problems and you discover solutions, do a lightning talk. Join the meetups. We try to do them as often as possible. We'd love to give you the opportunity to share what you're doing with ClickHouse. These meetups are entirely here to benefit the community and help help grow ClickHouse and help share the joy. So please do that, and you can contact me directly, or you can go to Telegram. We're active there. We're on Slack. There's lots of ways to contact us. With that, I'd like to thank our panelists today. So Alexi, thank you. Alexander, thank you. Denise, thank you very much. Thank you to everyone in the audience. Your questions are wonderful, and we will plan to do the virtual office hours. Right now, we're trying to do them about an every 90-day cadence for the SF Bay Area ClickHouse meetup group. We will plan to have another one in 3 months. So be thinking about questions. The next ClickHouse meetup that we'll be doing will probably be the themed ClickHouse for startups. We'll be looking at some interesting startup applications with using ClickHouse as a back end. So with that, thanks again, everybody. Have a good night. Have a good day, and we'll talk to you soon.
Thank you. Goodbye.